All right, now let's talk about something called Euler's method. Euler's method is a lot of fun. It's a little meticulous. I will give you that. So have your calculator ready. Suppose I tell you I have a curve, f of x, and suppose I tell you the slope is given by big F, evaluated at x and y, and suppose I tell you that I start at some point x naught, y naught. All right? I can approximate this curve by the slope at this point. So if I inch over to x plus h and x naught plus h, and I call this x1, then what is my y value going to be? My y value at this point, and it's not necessarily on the curve, is going to be y naught plus h times the slope of this curve. Now, if I go over at x1 plus h, and so recognize that this is going to be x naught plus 2h, realizing as we march across each of these, we're moving across at even intervals, then my y2 is going to be whatever my y1 value was, plus my increment, h, times the slope of this line. So we're going to wind up with this curve at each point that may or may not actually wind up agreeing with our actual curve at any particular point except for x naught, y naught. Now it turns out that our final point, xn, is going to be xn minus 1 plus h, which another way to write that is xn, x naught, plus n times h, because we're going to have moved over these even increments. So in x, we're moving over nice even increments, but in y, we're moving over different amounts depending upon what the point beforehand plus the increment times the slope, because we're moving over always delta x, and we're going up h times f at x at n minus 1, y n minus 1. This is just meticulous. What you're going to want to do is make a chart. All right, suppose I tell you that I want you to use your Euler's method to find this curve right here. Y prime is x minus y. And I want you to start at x equals 0. And I want you to use an h of 0.1. Well, let's start with x is 0. So x naught is 0 and y naught is 0. So you know what? I'm just going to go on and fill in all these x's because it's pretty easy. So this is 0.1, 0.2, 0.3, 0.4, 0.5. You kind of got the idea, all right? 7, got carried away there. All right, now let's find what our y values are. Our y values are always going to be, so y1 is equal to y naught plus h, f evaluated at x naught, y naught. So y naught is 1 plus 0.1 times, now what is my f? Now remember this is f. Okay, so it's going to be 0 minus 1, or 0.900. So y2 is going to be y1 plus h, f, x1, y1. So this is going to be, this is going to be 0.9, because I pull in that value right there, plus h is 0.1, and my values are 0.1 minus 0.9. Or this is 0.82. And you can see we can go on and fill all of these in, 0.758, 0.712, etc., until I get to the last one, that's 0.697. Now I've gone on and done this, and I've done an analysis. This is my slope field with my particular solution, and this is, let's see if I can do this, this is actually the Euler numbers. And I have filled my chart in where I'm following this formula. It's meticulous, folks, but it isn't hard. All you have to do is do an iterative, it's an iterative solution using Euler's formula, xn. Remember that, oh, let me get my pen here. Xn equals xn minus 1 plus h, and yn is equal to yn minus 1 plus h times f, evaluated at xn minus 1, yn minus 1. And remember that f of x, y is always your y prime. See if you can give it a go on this problem. Turn off the tape when you're done and finish your homework.